Hello everyone, and welcome to today's webinar. My name is Carlos Llopis and I'll be your moderator today. Thank you all for being here. Today we're talking about how supply chain planning, procurement, and materials teams can work with the data they already have in a more connected and usable way. Supply chain teams already have the numbers they need to operate, from current stock to consumption history and maintenance demand. The issue is fragmentation, because these data points live apart from one another, and planners must manually piecing the context together just to decide the next action on a part. Relying on that manual effort quickly becomes a liability when facing real-world pressures, like sudden supply chain delays, shifting maintenance requirements, or managing stocks across multiple line stations. So today, we want to look at one practical question. How can aviation teams turn the supply chain data they already have into a more reliable basis for spare-fast planning decisions? To help us explore that, I'm joined by Sander Debre, CEO at EXSYN. Thank you for joining.
Yeah, thank you, Carlos. Good to be here.
So, Sander, can you first walk us through how we're going to approach the topic today?
Yeah, sure. So the goal today is to mirror the way real supply chain planning decisions are made. When a planner, buyer, or materials team tackles a spare parts question, they generally need to understand three core things. First, the supply side. They need a clear picture of how suppliers are performing, whether that means spotting creeping turnaround times, managing aging open orders, or isolating bottlenecks like AOG critical delays and quarantine cases. Secondly, the current inventory position. It's all about ensuring purchasing aligns perfectly with actual consumption. We have to verify if an increase in inventory value is driven by sound operational strategy or if hidden costs are leaking through scraps, quarantine, or material loans. Thirdly, the forward-looking planning view. By bringing together upcoming maintenance demand, station level availability, lead times, and stock surplus, teams can confidently decide their next best action. So today's session follows that exact same logic. We'll start with vendor performance, move into inventory analysis, and finally look at inventory optimization and spare parts forecasting.
Thank you very much. So the agenda follows the workflow, right? Supply performance first, then current inventory reality, and then future demand planning.
Yes, because those areas are the ones that are connected. If supply performance is weak, that affects how teams can think about lead times and planning risks. If inventory movement is not understood, forecasting becomes less reliable. And if future demand is not connected to station level stock, teams may end up purchasing material that is already available elsewhere in the network. And that's why the workflow matters. The value is not in looking at each view separately, the value is in understanding how those signals connect before a decision is made.
And that brings us to EXSYN's role. Many teams already have an M&E system, procurement workflows, and sometimes a BI reporting on top. So where does EXSYN fit in that environment?
Yeah, so EXSYN sits alongside those systems. We're not replacing the operational system. The operational system remains very much where the transactions happen. What we do is help structure the data across those operational areas so that teams can work with a more trusted planning view. For logistics and supply chain, that means connecting supplier performance, order status, inventory movements, consumption, scrap, quarantines, loans, and future demand in one operational context. And that distinction is important. This is not about more dashboards for the sake of dashboards. It's about creating a more reliable basis for the decisions teams already need to make every day.
And then the planner still remains in control for the decision.
Yeah, absolutely. So the system should not take the decision away from the planner. The value is that the planner does not have to rebuild the picture manually every time. The relevant signals are brought together so that the planner can decide with better context and more confidence in the numbers behind the plan. And that matters in aviation because teams need to understand the logic behind the decision and be able to stand behind it.
And that's indeed a useful distinction. And with that workflow in mind, let's start where many supply chain issues first become visible: vendor performance. When an order is late, everybody sees the impact. But the planning question is whether that delay was truly unexpected or whether the pattern was already visible earlier. So let's begin here, how supplier performance becomes a planning signal. So when an order is late, everyone sees the impact. The more important question is whether the delay was unexpected or whether the pattern was already visible in the data weeks earlier. For this part of the conversation, I'm joined with my colleague Divya Das, who leads on the product side and works closely with customers and what the apps needs to do operationally. So Divya, From a product customer perspective, what teams can usually try to understand when they look at the supply performance?
Hello everyone. Carlos, for that, they are usually trying to answer a few practical questions. Which suppliers meet the expected turnaround times, which vendors are creating delays, which orders have been open longer than expected, whether there are AOG critical orders involved, and whether quarantine issues are clustering around specific suppliers or part numbers. These questions not just sit across procurement, but across procurement materials and supplier management almost every week.
Okay, and the question goes beyond identifying a late supplier, right? The deeper concern is whether supply behavior is becoming a planning risk.
Exactly. A single delay can happen. The pattern is what matters. When turnaround time starts increasing, the open orders start aging, or quarantine cases keep appearing around the same supplier, the team needs to see that pattern early enough to take an action on it.
Okay, and a delayed shipment or an overdue purchase order is something every supply chain has to deal with from time to time. So Olivia, when those individual delays start becoming something that teams need to pay closer attention to?
It usually starts when the same kind of issue keeps appearing. So having one delayed shipment or one overdue purchase order is manageable. But when the repair turnaround times slowly begin to stretch, or there are open orders staying in the system longer than they used to, then the teams start to question whether something is changing in supplier performance.
And I imagine those signals are not always obvious at first.
Exactly. They often build up gradually. You might see a few orders aging than a few, or you may notice that parts from the same supplier is repeatedly ending up in the quarantine. Each case may seem small at the moment, but when the team look across the data, a clearer picture starts to form.
And the value is in helping teams to see that picture earlier, right?
Yes, indeed. Supply chain teams are not just looking for a list of open orders or delayed transactions. What they need to understand is what is changing over time. Are there certain suppliers taking longer? Are there certain orders aging faster than expected? Are quality issues constantly coming back around the same suppliers or part numbers?
And once they can see those trends, they have more room to respond.
That's the key. If the team can identify these signals early on, they can follow up with the supplier, they can adjust the planning or prioritize the orders that could affect maintenance. The goal is to deal with the risk while it is still small enough to manage, than wait until it's affecting the aircraft availability.
Okay, thank you very much, Divya. And joining us as well is my colleague Inga from our platform developer team. So Inga, is that also that you see in your regular basis?
Yes. The phrase that summarizes it perfectly is we knew something was happening, but we could not clearly prove it until the impact was already operational. The data and the pattern existed, however, it was spread across multiple views and not visible in time.
So the issue is the visibility of the pattern rather than the availability of this data.
Yes, exactly, and that's where a structured suppliers view becomes useful. It helps teams prioritize which supplier conversations need to happen first, and it gives procurement or vendor management evidence for those conversations, reduced guesswork in supplier reviews and contract discussions. So recently we added some important KPIs to the vendor performance application, focusing on whether parts were delivered on time and in full quantity, as well as the quality of the delivered parts.
Okay, so let's make that more concrete with the first demo.
So the vendor performance dashboard is designed to give us a direct insight into the overall delivery performance of the different suppliers that I have as an airline in my technical operation. And in the dashboard, we get that understanding based on several key metrics that can be viewed either in general across all suppliers, or by using the filter for supplier here by means of an individual supplier. The overall metrics that we display, first of all, in terms of vendor performance, is the total on-time versus late orders. So this is a first indication on how well a supplier is fulfilling the orders that we raise with them. And then we have 3 additional metrics related to that. So the overall orders that are delivered on time, the overall orders that are delivered on time and in full, we call that the OTIF, and the overall orders that actually move into quarantine. And those high-level metrics already are a first indication of individual supplier performance. So we see here, for instance, deal aviation as an example, and then also in this graph here, their individual performance on each of those three metrics, on their OTD, their OTIF, and their QS. And of course, if I would want to see the specific metrics related to that, then I would simply click on the graph here, and then all metrics are automatically filtered for this individual supplier. The same performance over time for their overall order completion rates. And then if I scroll down a little bit further, we also see their monthly evaluation or their monthly evolving supplier turnaround time. And this turnaround time is calculated from the date we have actually raised the order with this supplier, and the date when each of those orders, date and timestamp when each of those orders have been delivered to us. And then some underlying metrics, as well as the different items that we are purchasing and requesting from this vendor. Associated to this is the actual quarantine dashboard. So in the quarantine dashboard, I'm able to get a more detailed view on orders or material that I order from specific vendors, which then ends up in quarantine at the point of receiving that material in the organization. So this is quite an interesting metric in terms of associated supply performance, because as a airline technical organization, this tells me something not just about the delivery speed of my vendors, of my suppliers, but also tells me something about their delivery quality. So from the material and spares that I order of them, how much of those are actually delivered properly with all the associated certificates without any damages, and can directly be issued to the aircraft for which we have raised that order. And together, these two dashboards provide meaningful insights in potential bottlenecks in supply performance that might be associated to individual suppliers, that might have specific root causes in quarantining items, that might have specific root causes in ability to deliver to specific bases. So providing a means to go from a high top level overall supply performance across my entire approved suppliers or individual suppliers, all the way down to potential individual bottlenecks associated with quarantined items, quality of material, individual bases, and individual stations that are being provisioned.
Vendor performance gives us a view on the supply side, supply behavior, and where it's creating planning risk. So now let us turn to the inventory side now. The next question is whether we are buying and holding stock in a way that reflects what the operation is consuming. Divya, when the cost pressure increases, what are the inventory questions teams usually need to answer first?
The questions become more specific. Is the stock moving? Are purchases keeping pace with consumption, or purchasing moving ahead of it? Is inventory value growing for the right operational reasons? Are scrapping patterns creating hidden waste that nobody has connected back to the source?
So then one thing that we quite see often is that aviation organizations already have a lot of the information they need: purchase orders, stock movements, repairs, loans and exchange, scrap material. All of that is usually being recorded somewhere.
Yeah, that data is usually there. The harder part is helping teams see how those pieces connect. In day-to-day operations, each area is focused on its own process. For example, procurement is looking at purchase orders and supplier deliveries. The warehouse team is managing stock levels and material movement. Repair teams are tracking components sent out for repair to vendors, and quality is following up on quarantine parts and inspection findings.
So every team is seeing part of the picture, but often from their own screen or report or workflow, right?
Exactly. And that makes sense operationally because each team has its own responsibilities. But it can also mean that people spend a lot of time responding to individual issues without seeing what those issues are telling them when put together.
Okay, so can you give us an example of how that might show up?
Sure. A buyer might see that a purchase order is overdue. At the same time, quality team might see more quarantine material from the same supplier. The warehouse team may be seeing higher consumption of specific part, while the maintenance planning is starting to feel the pressure because the availability is getting tighter.
And each of those things might seem manageable when looked at separately, right?
Yes, but when you bring them together, the story becomes much clearer. You may be looking at a specific supplier issue, a quality trend, a planning risk, or combination of all three. That is where a connected view becomes really valuable.
So in the end, it's about helping teams move beyond those individual transactions.
Exactly. When purchasing, inventory, repair, quality, logistics, all this data is brought together in one environment, teams can easily start to understand the relationships and trends much earlier. They can see what is changing, where there is pressure building, and what actually needs attention next.
And that gives the organization more time to respond.
Yes, it supports better planning and faster decision making. And most importantly, it allows the teams to act before small operational signals turn into bigger supply chain problems that in turn affects maintenance schedule or aircraft availability.
Okay, thank you very much, Divya. Inge, what does that look in practice for teams you work with? Jetfly comes to mind here, right?
Yes, often it looks like a manual reconciliation, and Jetfly is a perfect example. They operate more than 70 Pilatus PC-12, PC-24 and Cirrus jet aircraft across European business aviation. During their AMOS implementation, they identified this exact need for stronger analytics and KPI visibility across their material management and inventory. Without that collective view, it often looks like a manual reconciliation. So someone must align purchase activity with consumption history, explain why inventory value increased, check whether scrap behavior is repeating, and connect quarantine activity to the supplier or the part involved. So this is done every time the finance team needs a detailed overview.
And which is that exactly the kind of work that should disappear when the work with the views of are structurally connected. So let us see how this looks when those views are brought together in the next demo.
So inventory analysis on the EXSYN platform is driven by two main dashboards in our application. And first of all, it's purchase and consumption that we see on screen here. And this is basically a detailed analysis on my inventory behavior. What am I buying as an organization? What am I consuming? What am I issuing to the aircraft? And how does that translate in actual value, monetary wise? So is my inventory value going up? Is my inventory value going down? Ideally, it should either be stable or go down. And what are the associated underlying trends with those? Are those inventory increases or decreases or stabilizations related to individual bases in my network? Are they related to individual material that I'm consuming more frequently all of a sudden? Is it related to specific aircraft in the fleet, etc., etc., etc.? And then I can actually get the individual details of the inventory transactions. So this tells us something as a logistics organization, as an engineering organization, where my material spend is happening, and where the material consumption on my fleet is happening, either on individual maintenance basis or related to individual aircraft in my fleet. Related to that is what we call the order statistics. So this gives us a fine-grained overview in various insights related to different material orders that I'm raising with my suppliers. So previously we have seen vendor performance. This is statistical insights and root cause analysis around specific orders, around purchases, around repairs, around pool requisitions, exchange orders, etc. So we see how much we are spending on each of those individual items. So I could easily select here, for instance, in the order type column, I could easily select the purchase order as an order that I want to track. And that will directly give me all the related insights for all the purchase orders that I am raising as an organization. It will tell me trends over time in terms of value, in terms of spend accumulation, and the priority distribution. So how many of my purchases are actually AOG critical, what is routine replenishment, what are critical orders, etc. I can see the different hubs and stations where that material is being sent to, different material planners in my organization. So I can even use this for efficiency analysis around my individual material planning department. The total raised orders over time. I can see individual statistics related to the suppliers. So how much are we actually spending with individual suppliers? Ultimately to support inventory analysis decisions. So which material do I need to keep on stock? Which material do I need to monitor more actively? Where do I have bottlenecks in my supply chain, in my logistics supply chain, in order to satisfy material demand for aircraft at the point in time where I need it, on the location where I need it. And that's both for scheduled and unscheduled maintenance. So purchase and consumption together with the order statistics tells us something about the inventory behavior that I have within my airline, within my technical engineering organization, and how to best optimize that to ensure availability of material, but also ensure an efficient cost level for my supply chain.
So at this point, we have purchase, consumption, order value, and order priority in the same operational view. That already changes the conversation from how we match a spend to what drives the spend. So Sander, let us look now at the areas with the next demo.
So in terms of hidden inventory costs, two clear areas are parts and tooling that we loan from other organizations temporarily, as well as material and parts which is being scrapped from our inventory. And for both scenarios, the EXSYN platform provides quite some detailed insights into loans and scraps. So the dashboard that we're looking at right now is specifically analyzing the loan behavior of our organization. Loaning of aircraft parts, loaning of tooling and equipment, for instance, to give us an insight on the specific aircraft parts or tools that we are loaning most frequently, most often. Where do those loans happen for which specific maintenance checks, for which aircraft, for which bases? From which suppliers are we most frequently loaning that material and or tooling from, in order to see if there are specific supplier related trends, as well as give us a snapshot of the current situation. So how many open loan orders do we have? What financial value does that represent? Because every day we have an aircraft part or tooling or equipment on loan that represents a specific cost to the organization. How much items do I still need to return to the organization that has loaned me that specific tool or aircraft part, as well as the specific details of each individual item that I have on loan as an organization, including the financial value that represents. So this dashboard gives us as a logistic organization a very clear view on tooling that I might have on loan currently, as well as items that I have loaned historically, and not just tooling, also aircraft parts. And this is particularly useful as an organization to understand that behavior. So why are certain tools or parts loaned? And what would be a financial business case to potentially invest in those, or to source alternatives from the market. Secondly, related to hidden inventory cost is scraps. So actual material that I have on inventory, and that is being scrapped from the inventory due to a specific reason. Most of the time that reason can be expiry dates, or that can be damages or items being beyond economical repair, for instance. So this shows me the behavior from my organization in terms of scrapping material from inventory. It shows me a specific trend over time. So do I have specific seasonal dependencies in those in terms of value that I'm scrapping? It shows me the items that I'm most frequently scrapping. So is there specific material or specific parts from my inventory that are being scrapped more often than other items? In terms of total quantity as well as in total value. So this is to distinguish between volume and actually the monetary value that represents. So in this case, scrapping a significant amount of packings might be a lot in terms of volume, but it might not represent a significant cost to the organization. However, scrapping a pitot tube, which is quite a costly item, would represent a specific significant cost to the organization. So this allows me to understand what I am scrapping, what the root causes of those are, the individual bases and stations where that happens, the items by value, and the items, the scrapping events themselves. So together with loans, the scrap and loan dashboard provide us a good understanding about two very specific hidden costs that could exist for an organization when it comes to managing their inventory and their supply chain. And that is the material that we are scrapping from our existing inventory, as well as tooling, equipment, and aircraft parts that we might loan from other organizations and represent a significant cost to the organization itself.
Those views give us the current picture, vendor behavior on the supply side and inventory behavior on the internal side. Planners also need to look forward. The next question changes from what happened to what we should do next. Divya, given those starting points, what does the forecasting workflow look like?
The aim of the workflow is a trusted demand view, so planners can make better decisions earlier. The forecasting engine combines several inputs, the upcoming maintenance events and work orders. It considers the historical consumption, inventory analysis and inventory availability across stations, unscheduled events and operational risk indicators, alternate part availability, which is often the missing piece where planners are weighing whether a shortage is real or coverable.
Okay, and the output of that view connects directly to the planning workflow.
Right. The principle is to transfer the material before purchasing. So first check whether the material can be transferred from a station that holds surplus stock. Second, check whether a pool or exchange option is available. And only when neither is viable, raise a new purchase order. That sequence supports cost control and reduces operational risk in the same workflow.
Okay, thank you very much, Divya.
Right.
So far, we have looked at what has already happened, but planners also need to look forward. This is where the question changes from what happened to what we should do next. And this is also the area where static stock targets often start to show their limits. Inge, this was an important part of the Volotea case, right? So what made static stock targets difficult for them as the network expanded?
Yes, Volotea operates a growing fleet of Airbus A319 and A320 aircraft across an expanding network of bases in Southern and Western Europe. As the network grew, spare parts planning was largely coordinated through Excel and predefined idle stock quantities at each base. The challenge was that aircraft, materials and maintenance activity were moving across stations continuously, and planners had limited visibility into where inventory was available across their network. So a shortage at one base often could have been resolved by a transfer from another, but that information was difficult to service in time.
And this actually highlights a broader issue, right? The trigger for Volotea was a multi-station spare parts planning, but the underlying need is one that we see often: reliable logistics and supply chain insights on top of the operational system.
Yes, indeed. Whether the trigger is network expansion or the implementation of a new system like AMOS, operators consistently identify the need for stronger analytics and KPI visibility across their material management, procurement, inventory, tooling, and operational performance monitoring. The goal is always a structured planning view that the team can actually use day to day.
And given those starting points, what does the forecasting workflow look like?
The aim is a trusted demand view, so planners can make better decisions earlier on. The forecasting engine combines several inputs, so upcoming maintenance programs and work orders, historical consumption, inventory availability across the stations, but also lead times and demand variability, as well as unscheduled events and operational risk indicators, and alternate part availability, which is often the missing piece when planners are weighing whether a shortage is real or coverable.
And is the output of that view that connects directly to a planning workflow?
Yes, that's right. The principle is transfer before purchase. So we first check whether the material can be transferred from a station that holds surplus stock. And secondly, we check whether a pool or exchange option is available. And only when neither is feasible, raise a new purchase order. And that sequence supports then the cost control and reduces operational risk in the same flow.
Okay, thank you very much. So let's look at this with the last demo.
So everything that we have seen until now is retrospective analysis on trends related to my inventory, on trends related to my supply chain and processes. Very useful in order to identify root causes for specific spends or issues that I have or bottlenecks that I have in my supply chain processes that can be resolved in order to ensure on-time availability of material for maintenance operations. However, in the EXSYN platform, there's also a means to do or to have an overview of future upcoming material demand and predictions for individual bases, and what is advised to do in order to satisfy that specific material or spares demand. So we call that the spares demand forecast, and this overview basically gives material planners insights into future material demand, either driven by scheduled maintenance activities or unscheduled maintenance activities, and how that translates into the material requirements on specific bases in my network, on specific maintenance bases. So for instance, if I look at station AAN of November here, the system will show me the different recommended material actions over time in order to make sure that material requirements from maintenance can be met. And in order to do that, it suggests that I need to place 70 outright purchases. I need to transfer 73 items from other bases in my network, and I need to raise 70 requests to my pool provider. And then if I scroll a little bit down, I can actually see the individual material events, specific suppliers where that needs to be sourced from, and until when that specific material needs to be made available. Now, this station view, as we call it, is based on recommended minimum stock levels at bases and translating that to future material demand due to maintenance that needs to happen on those bases. A second view that the system provides to material planners is the actual optimum calculation. So this is a representation of expected material or recommended material planning actions, either purchasing material, transferring between bases, or requesting items from a pool provider, based on a machine learning algorithm that looks at historic consumption on bases, that looks at upcoming scheduled maintenance activities, expected unscheduled maintenance activities, based on components installed on the aircraft, age of the aircraft, age of those components, etc. So it takes all of that information in order to produce an overview for each individual base of the suggested material actions. And together with the ideal view, material planners use this to determine which specific material actions to take, what to purchase, what to transfer between bases, and what pull requests to raise in order to make sure that that material is available on time at the base where it is needed, at the moment where it is needed. That also means that those material planners have a detailed view at their availability through the spares data viewer, where they can see the actual detailed calculation for each of the individual maintenance events. So we can even go down to the individual work package level. We can go down to the individual station level. We can even look at the individual recommended spares replenishments based on expected high value parts on individual aircraft. So this is combining AOG risk calculations from our AOG risk monitor with the translation of that AOG risk into specific material requirements. So really be able to see, as a material planner, be able to see the underlying justifying calculations of why specific material transactions are recommended. And then ultimately, it also translates that into a potential surplus for the inventory. So based on upcoming maintenance on different bases and the current inventory that is available on those individual bases, what could be potential surplus inventory for those different bases? So basically material that they keep on stock at those bases, for which the system has already detected that it will not be used for the next 12 months, 24 months and 36 months of maintenance operations. And that could actually be a justification to see if that specific surplus might need to be sold on the market or needs to be transferred to different bases where that material might actually be required. So next to recommending specific material actions in order to meet future material demands, the spares forecast predictions also looks at the outcome of those predictions in terms of potential surplus inventory on those individual bases. And together with the analysis that we have seen from logistics and supply chain dashboards, the spares demand forecast then provides that forward-looking view in conjunction with that retrospective analysis that is done in all the other dashboards within the supply chain area of our system. And both combined really give a powerful tool to material planners to identify potential issues for resolution based on historic trends, as well as expected material actions in order to satisfy future maintenance demand.
The picture comes together here. Vendor performance gives a reliable view of the supply side. Inventory analysis tells us where we stand on the current stock. Spare parts forecasting points to what's coming. And the transfer before purchase logic translates us into daily planning decisions across the network. So let's now close with a short summary. So now that we have seen the different parts of the workflow, I want to bring back to the bigger picture. Divya, if we look at what we have covered today, how would you summarize the practical value of the logistics and supply chain analytics app for the teams using it?
To summarize, there is 3 principal outcomes. The first is supplier control. With the vendor performance view, teams can look at turnaround time, open orders, aging orders, AOG critical orders, the delivery performance, and quarantine-related supplier patterns in a single operational context. Tracking supplier performance requires identifying developing patterns early enough to intervene. For procurement and vendor management teams, spotting these trends creates a factual, solid basis for supplier conversations, be it contract reviews and operational follow-up. The second outcome is inventory visibility. The inventory analysis view brings purchasing, consumption, order statistics, scraps, and loans into the same planning context. This gives teams direct visibility into the exact operational factors driving inventory value. It allows them to quickly pinpoint where urgent AOG orders are hitting, track repeating scrap issues, spot quarantine bottlenecks, and uncover the cost exposure from active loans. The third outcome is, of course, planning confidence. The spare parts forecasting connects the forecasted demand with station level stock, surplus inventory, alternate part availability, and the transfer before purchase workflow. This in turn equips planners with a highly reliable forward-looking demand view right where they need it. With that clear context in hand, the planner can better decide whether the best operational move is to transfer, pool, or purchase material.
Thank you very much, Divya. But Sander, from the EXSYN perspective, how should teams think about these apps after what they've seen today?
Okay, so now that we have seen the app in context, I think the important point is that each view supports a specific part of the planning workflow. Vendor performance helps teams understand whether the supply side is creating risk. Inventory analysis helps teams understand what is happening inside the stock position today. And spares forecasting helps teams connect that current position to future demand. Individually, each dashboard can answer a specific operational question, but together they create a more connected logistics and supply chain picture. When planners must manually cross-check systems, the supply chain slows down. EXSYN bridges that gap by connecting your raw operational data directly into the material team's workflow. We take the friction out of combining supplier history, inventory status, and maintenance demand. And the result is a clear, reliable baseline for every single supply chain decision.
And that also connects to what we discussed at the start, that most of the teams have already the data. The challenge is whether that data is connected enough to support a decision when a decision needs to be made.
Yeah, exactly. The operational system remains the source of the transaction, and EXSYN works alongside that system to create a trusted planning layer on top of it. So when teams use the logistics and supply chain app, they are not replacing their existing workflow. They are actually strengthening them with a clearer view of supplier performance, inventory movement, and future demand. And that is what helps reduce manual reconciliation, reduces guesswork, and gives teams more confidence in the number behind their material plan.
Then, so if we want to bring today's session into one final thought, it will be like this, like spares parts planning becomes much more stronger when supplier performance, inventory activity, and future demand are not treated as separated reporting exercises, but as a connected parts of the same planning workflow. That is what the EXSYN and Logistics Supply Chain Analytics app is designed to support. It helps teams understand whether supply pressure is building, where inventory and value or availability needs attention, and where future demand should lead to a transfer, a pull option, or a purchase decision. So with that, we will move into your questions. Please type your questions in the box located to the right of the main webinar window, and we will go through as many as we can. I think we have some questions already. Let's start with the first one. Okay, the question is, what is the criteria used to benchmark vendor performance, and is it measured against the acceptance target or actual delivery?
The vendor performance is tracked based on the actual delivery, so it takes into account the time when an order was issued and the date and time when an order was received or after it has completed the component inspection and received. So we track it based on the delivery date and not on the target date. But we do have some new indicators on the dashboards, which we saw in the demo, which allows to at least show if an order was delivered on time or later, if there has been a target date set on the order.
Thank you very much. And next question is, do you benchmark vendor performance across different airlines or MROs?
Currently, we do not benchmark vendor performance across different airlines or MROs. We leave it to the relationship that each customer has with their suppliers, so we do not benchmark it.
Okay, and does the vendor performance view track on-time in full deliveries alongside the general turnaround time?
Yes, we do. As we saw in the demonstrations, that we do have metrics that track if a certain order was delivered in full or was it delivered partially. And as I mentioned before, if there is a target date assigned to it, if the order was delivered within the target date or if it was late.
Okay, and next question is, is time spent in quarantine taken into consideration when establishing a vendor's delivery performance?
Of course, the time spent in quarantine is taken into account, as we always track the order as delivered after the component inspection is completed and the part is received in full.
Okay, thank you. And when evaluating an inventory behavior, can the app highlight if an increase in inventory value is tied to a specific aircraft or a specific maintenance base?
Usually, yes, because the purchase and consumption dashboards do show how the consumption of materials is against the purchasing that has been done. Doing a drill down on these will allow our planners to go in depth to see what contributed to the increase in consumption.
Okay, thank you. And next question is, can we track the total accumulated financial value of all open loan orders directly within the system to build a business case for purchasing?
The loan dashboards does take into account the open financial value on the open loan orders. So yes, they can have an overview of the financials linked to the open loan orders. Yes.
Thank you. And can the quarantine dashboard isolate quality issues down to a specific part number from a specific vendor to help with contract reviews?
Yes, we do have a very customized list of filters on the different dashboards and features that allows to go in depth to the details of what they see in the dashboards. So yes, it is possible to see what is the reason behind the quarantine and which suppliers parts frequently go into quarantine.
Thank you, Divya. And next question is, what about uncovered hidden inventory costs, like repeating scrap issues or active loans? Will the app uncover those that finance teams might not see?
Yeah, the reason for such dashboards is indeed to give such a perspective to the finance teams that they are able to see or get a clear picture of items that are scrap based on the sheer volume and the value. So yes, it does help uncover hidden costs.
Thank you. For next question is, for the spares part, the spares demand forecast, how exactly does the machine learning algorithm balance historical consumption data against upcoming scheduled maintenance events?
The spares demand algorithm looks at the historical consumption on a certain basis, and it also looks at the unscheduled activity that has happened on these bases in that time period to determine what could be the upcoming demand for that specific list of parts.
Okay, next question is, does the app help procurement workflows like converting part requests to orders, or does the operational system remain the source of the transaction?
The operational system always remains the source of transactions. So our apps sit on top of the system to provide analytical and planning view, but we do not take over the responsibility of the operating system.
And when applying the transfer before purchase logic, does the app factor in the logistical cost and lead time of transferring a part from another base versus buying it locally?
Yes, it does take into account the lead time and the station level inventory availability before making the recommendations.
Perfect. Next question is, how does the app factor in alternate parts availability when assessing if a potential shortage is a real operational risk or a coverable one?
The spares workflow indeed looks at any approved alternate or interchangeable part before showing the recommendations. So of course, it does take the part alternate into account while making the recommendations.
Thank you. I think we have time for a couple more. Are the dashboards customizable based on a specific airline or MRO requirements?
The dashboards that we have currently are off the shelf and they are not customizable. But of course, when we do have new feature requests or requests to add things that would add value to the dashboard, we always take that into consideration.
Okay, and how does the app help planners to retain full control of the final decisions while removing all the heavy lifting of manual data gathering?
As I mentioned before, the app is only intended to do the heavy work that the planners have to do in Excel or getting the data together to understand what would be the right decision to take. So we in the end show possibilities that would work best for the planner, and the decision making is still left to the planner itself.
Again, if we already use an M&E system and a BI reporting tool, what's the value for adding this connected planning layer?
I would say the overall benefit is having like a unified view. So it's not replacing anything from the M&E system. Having a BI layer with multiple reports also works. In the end, what our platform provides is a single layer where all the data set is connected, and the users are easily able to navigate between the dashboards and see the links between what they see and what needs to be improved, or where action needs to be taken.
Thank you. And one last question is, how quickly can we start seeing actionable historical patterns about, for example, supplier quality and quarantine bottlenecks using these dashboards?
Usually almost immediately. If the IT requirements are in place, then we do have direct access to the M&E systems, and once we have that, then all dashboards are populated right away, and they are able to see immediately what drives the different patterns.
Okay, thank you very much, Divya. That's all the time we have for today. Thank you all for attending. Hope you have a great summer, and see you in the next webinar. Bye.
Bye.